Okay, so this week we're going to look at section 2.2. Okay, it's on unit circle trigonometry. We'll spend the whole week on that one section, and we kind of build, as we go each day. For today, I don't think we're going to use the calculators at all, probably today and tomorrow. But on Wednesday, I'm going to show you some stuff on the calculator, like how you can type in trig functions on the calculator. You won't need anything advanced like a graphing calculator, just a basic scientific calculator. All right, so we're going to start out by looking at this diagram. All right, so the first thing is I've drawn a circle. And it's a circle that has a particular radius. Okay? It has a radius of 1. Whenever you draw a circle with a radius of 1, that makes it a unit circle. Okay? That's all that unit circle means. Circle with radius 1. Okay, and going around the circle, I've labeled 4 different angles: 0, 90, 180, and 270 degrees. Now, all those angles that I labeled are special because they're right on the axes. And does anybody remember when you draw in the axes, that separates the plane into 4 regions? Does anyone remember what those 4 regions are called? Those 4 sections. How about Peter? Quadrants. Yeah, quadrants. Okay, so we call these angles quadrantal angles because they're on all the boundaries between the quadrants. Now, has anyone ever done unit circle trig before? Yeah. Okay, so the idea is that you could give me any angle that you want. Okay? Say you give me, just to make it easy, a 45-degree angle. Okay? I could get my protractor and draw it exact, but I'm just going to kind of estimate it. All right. And I'm going to make it a little bigger. Okay, so the idea here is that I can take any angle that you give me, okay, including like a 45-degree angle. I could put it right there inside the circle. And at some point, the terminal side of that angle, which is the side that's on an angle, not the horizontal, is going to hit the edge of the circle. Right? And let's say that that's, again, at 45 degrees. Well, okay, the idea is that every point, like the one I just labeled, 45, and I could do any other angle that you give me, there's a coordinate for that point. Okay, I'm not going to tell you what that is right now. But there is a coordinate to get to 45 degrees. Starting from the origin, you can go over a certain amount, and you can go up a certain amount. And does anybody know how those 2 amounts would compare in a 45, 45, 90 right triangle? The amount you go over to the right and the amount you go up. Yeah, I'm not going to tell you what the amounts are, but there is a connection between them. They're the same. Because in a 45, 45, 90 triangle, 2 sides are the same. So the amount you go to the right and the amount you go up would be the same. Okay? And that's the whole goal. You have to figure out that coordinate. That's what you want to be able to do. And then, once you figure out the coordinate, you can do the trigonometry part, okay, which is maybe to find the sine of 45 degrees, or the cosine, or the tangent. Okay, we're gonna go through all 6 basic trig functions. But the first step is somehow figuring out the coordinates for that angle. One thing about unit circle trig is you don't use it for every single angle that you can have. So if you gave me like 12.7 degrees, there's no way I can figure out the coordinates easily for 12.7 degrees. Okay. Coordinates that I can figure out, pretty easy, are 0, 90, 180, 270. We're going to go through those 4 next. And then any angle that's a multiple of 30, like 30, 60, 90, 120, or angles that are multiple of 45. And there's some overlap there too. Right? But those are the angles that we generally use unit circle trig for. Okay? Multiples of 30 and multiples of 45. All right, so let's see if we can figure out the coordinates for the quadrantal angles. These are probably the nicest coordinates that we work with because they're always on an axis. So if you have a point that's always on an axis, in your coordinate, one of the numbers is always what? How about Victoria?
0.
Yeah. If you have a point on an axis, one of your numbers is always 0. So anyone think they can tell me the coordinates for 0 degrees? Given all that you've done is start from the origin and go to the right. And you know the radius of the circle, so that tells you how far you went to the right. How about Ileana? 0, 1, we're going to get to, that's going to actually be for 90. Yeah. So 0, 1 means we don't go left and right, we just go up 1. This is 1, 0. Katie, how about 180?
-1, 0.
Yeah. -1, 0. And lastly, let's do 270. How about Matt? What would 270 be?
0, -1.
0, -1. So anytime I ask you to do a trig problem that involves one of these 4 angles, that's your first step. Figure out the coordinate for whatever angle I'm asking you about. Any questions on how we got the coordinates for those 4 angles? Now, sometimes I ask what's the coordinate for 45, and sometimes people say 1, 1. Does anyone have any thoughts about 1, 1? Do you think that would be the coordinate or not? And if not, how come? Rudy, what do you think?
I'd say no.
Say no? Do you tell me why 1, 1 wouldn't be the coordinate for 45? Not sure? Ashlyn?
It's not, like if you were to make that circle into a square, it's not all the way to the, like, you can see where 1 is, where that dot is.
Yep.
If you make a line right where that dot is, that 45 angle is not exactly on that line.
Yeah, it's not. 1, 1 is way off the circle. 1, 1 is way up there. That's not on the circle at all. So the coordinate for 45 degrees is a number smaller than 1, comma, and then the same number again. But again, for today, I'm not going to tell you what it is. We'll look at that more tomorrow. All right, so this is everything I just said to you, so I'm not going to say it all again. Whatever. Okay, so the idea, you've got to find the coordinate for a point on the unit circle. And when you're working with a angle, remember there's 2 different directions we can measure angles in. We can go counterclockwise, and we can go clockwise. If you measure an angle counterclockwise, it's positive. And I think I already mentioned this in the notes last week. If you measure an angle in the clockwise direction, okay, then that's a negative angle. Okay, and let me bring up a program just to show you that. Okay, so again, just to show you how that works. As I start to move in a counterclockwise direction, okay, it shows me my angle, 47 degrees, and it's also showing it in radians, okay, 0.82. If I go the other way, now we're looking at a negative angle. So let me show you 2 angles that would have the same coordinate. Negative 90. And if you go around the other way, 270. So that means for the purposes of doing something trig related, like sine, cosine, or tangent, it doesn't matter which one of those two numbers you work with. You can think of it as 270, or you can think of it as negative 90, because they have the exact same coordinate. And that's all you need to do the trig part. You need the coordinate. Which angle do you think we would prefer to work with? Thinking of it as negative 90, or thinking of it as positive 270? Positive 270. Okay, generally, we want to think of angles as positive. Okay, it just makes it easier so we don't have to deal with a negative. And anybody see what you add to negative 90 to turn it into 270? How much? Add 3. See how much you added? Yeah, Alex?
360.
You added 360. I brought the point around 1 revolution. Okay, so I added 360. And you can do that to any negative angle. All right, before I mention that, I'm going to mention something else while I still have this up. What about, instead of having a negative angle, what if I had an angle that went around more than 360? Okay? When we start to get into angles that the number gets bigger, we want to make it smaller so it's easier to work with, because there's another angle that has exactly that same coordinate. Anybody remember what angle is the same as 450 degrees? Yeah, Ryan? Negative 180 would be more over here. Yep, because you'd start at 0 and you'd go halfway around the other way. So it's a good guess, but not negative 180. 90. 450 is exactly the same as close enough to 90. Same coordinate. What did I subtract from 450 to change it to 90? 360. Right? So the point here is if you have an angle, you can add or subtract 360 to it as many times as you want, and you're still going to land exactly back at the same spot. Okay. So if you have an angle that's too big and you want to make it smaller, you can subtract 360 as many times as you want until you get an angle that's between 0 and 360. So like if you said to me, what would be the coordinates for 2,110 degrees? Off the top of my head, I have a hard time visualizing an angle that big. So if I took 2,110 degrees, I would just subtract 360 a bunch of times till I finally get it small enough and I can say, oh, okay, 310, that's a little bit short of going all the way around. 360 would be all the way around. 310 is 50 degrees before that. But thinking about it as 2,110, that's, I didn't know that. Okay, and also the same idea with the negative. So if you've got an angle that's in the negatives, generally what we do is we add 360 as many times as you need to until the angle is positive. Okay? Always try to get the angle between 0 and 360. We don't care how many times that this angle has gone around. All we care about is where did it stop? What's the xy coordinate? Okay, and just to show you numerically that it'll always come out the same, let's type one in. Let's type in 405. Okay, and what I'm going to do is take the sine of it. Okay, remember that number, 0.707. What do you get if you subtract 360 from 405 to make it smaller? Yeah, Alex?
45.
You get 45. So now I'm going to type in the same thing I just did. I'm going to type in, for the same function, I'm going to press sine again, but I'm not going to type in 405. I'm going to type in that number minus 360. Okay? And remember the 0.707. 45, sine, I get exactly the same thing. Okay? So it's a lot easier to work with 45 than it is 405. All right, so next thing we're going to look at is the definitions of all 6 trig functions. Okay. So it's good to be able to get the coordinate. Okay, you've got to be able to get that x and y value. But then you have to know what to do with it. Okay, you have to plug it into a formula. So the following definitions I'm about to give you are based on figuring out that coordinate we just talked about. Okay, the coordinate that corresponds to an angle. Okay, so the first 3 trig functions we're going to look at are sine, cosine, and tangent. Okay, I've written out their full names, but from now on we'll use abbreviations. Faith, do you know the abbreviation or the letters you use for sine?
S-I-N.
Yeah, S-I-N. And Mason, do you know the abbreviation for cosine? Yeah, C-O-S. And Orion, how about the abbreviation for tangent?
T-A-N-G.
Just T-A-N. Yep. So all the abbreviations are always 3 letters. Okay. And those are the definitions of those trig functions based on you knowing the coordinate we just talked about. So if I give you an angle, you find the coordinate for it. If I wanted to know the sine of your angle, all you need to tell me is the y value of your coordinate. That's the answer. If I asked you for the cosine of an angle, all you need to give me is the x value of the coordinate. So sine and cosine only use one part of the coordinate. They don't use both parts. Tangent uses both. Okay, so if I ask you for the tangent of an angle, you find the coordinate, then you take the y value, divide by the x value. Okay, any questions on those 3 definitions? Okay, and there's 3 other trig functions that are related to these. Does anybody know the names of the other 3 trig functions, or even just one of them? About Paige? Yeah, secant, cosecant, and cotangent. And I'm going to show you the first one. And I think from there, you'll probably see a pattern if you look at the one that's on the left and you look at the one that's on the right. Okay, so cosecant, that's abbreviated CSC. Normally, the abbreviation just uses the first 3 letters, but we can't do that. We already use COS somewhere else. Okay, so cosecant. And Haley, do you see the connection between, like if I were to write it like this, the formula for cosecant and the formula for sine? Yeah, it's the reciprocal. Normally we don't put y over 1, but I just did that to really emphasize it's the reciprocal. Okay, so knowing that it's the reciprocal, Molly, what do you think the formula is for secant?
1 over x.
Yep, 1 over x, abbreviated SEC. And Robin, what do you think the formula is for cotangent. X over y. Good. And that's abbreviated COT. Good. Any questions on those 6 definitions? And really, you only have to remember the 3 on the left. Because if you can remember those, just flip them all, and then you get the other 3. Okay, so you just have to just remember that. All right, so this part, I think I already mentioned. Yeah. Those angles that are right on the axes that divide it into 4 quadrants, those are your quadrantal angles. And Emily, what did we say? The quadrantal angles always have what number somewhere in their coordinate? A 0. And Hayden, is there any operation in math that you have to be careful if you're going to use a 0? Like think of like arithmetic operations. Division. What about division and a 0? You can't divide by 0. So we're going to have to keep that in mind because that might happen in some of these formulas. It's very possible that you have an x or a y value that's a 0. Okay, so we have to remember what happens when you divide by 0. Okay, so that's going to come up. All right, so now how do we put all this together and actually do a problem? So step 1 is find the coordinate. If you wanted to shorten it up, you could really just say that. Find the coordinate. Okay. It's a coordinate on the unit circle, and that coordinate represents an angle. I think the first one I drew for you guys was like a 45, and I said that it has a coordinate. So that's your first step. Figure out the coordinate. Sometimes they do that step for you. If you're given the coordinate, then you can just move right on to step 2. Okay, any questions on step 1? Find the coordinate. Okay, step 2. Step 2 is to take your coordinate that you just got in step 1, and using the definitions, the 6 definitions that I just showed you on the other page, plug your values for x and y into those 6 definitions. Now, which definition do you use? Well, it depends on what they want to know. If they want to know sine, look up the definition for sine and plug it into that. If they want to know cotangent, look up the definition for that, plug in your coordinate into that formula. Okay, what we'll do is we'll practice finding all 6, okay, in class. Also, if you have to do step 1, there's only 4 angles that I've taught you how to find coordinates for. The very first 4 angles we talked about. Rudy, do you remember what the 4 angles were that we were able to find coordinates for?
0, 90, 180, 270.
Right, 0, 90, 180, 270. As of right now, those are the only 4 angles you know how to find coordinates for. Or the only ones I've shown you. Tomorrow and the rest of the week, we'll look at figuring out the coordinates for multiples of 30 and angles that are multiples of 45. Okay, so here's a coordinate, and it says let this be a point on the unit circle, and it represents some angle. Okay, I'm not going to tell you what the angle is. because you don't need to know that. What I want to know is the 6 trig functions of that angle. Okay? And at first, sometimes people are like, well, how can you figure out all the trig functions of the angle if I don't even tell you what the angle is? You don't need the angle, you need its location. Where is it? Or another way to think about it is if you met someone on the street, how could you describe something about them without knowing their name? Well, that's easy. You don't need to know their name to describe what the color shirt they're wearing or their eye color or hair color. You can describe a bunch of things about them without knowing their name. Same thing here. We're going to describe some things about this angle without even knowing its name or how big it is. Do you think that this coordinate represents an angle that's a 0, 90, 180, or 270? Emily, what do you think? Does that look like a coordinate for a 0, 90, 180, or 270? No, it's not. This is a coordinate for some other angle, which again, I'm not going to tell you what it is right now. But it's something besides 0, 90, 180, and 270. So for now, I have to give you the coordinate. Okay, -1/2 root 3 over 2. And now we'll find the 6 trig functions for that coordinate. I'm just going to copy it down so we have it. All right, so how about Irene? What was the definition for sine? Y. And what's our y value in this case? Yeah, square root of 3 over 2. You're done. Okay, that's it. That's all you have to do to write the sine. Zach, what was our definition for cosine? X. And what's the x value in this case? -1/2. Those are the easiest two to do because they're directly from the coordinate. You don't have to divide anything. You don't have to flip anything. All the other ones, you're either going to have to do some division or flipping. 2 things you have to remember. 1, you don't ever want to leave fractions over fractions. Okay, you always want to simplify. And 2, where do you never want to leave a square root? On the bottom of a fraction. So if that happens, we need to fix it. Cameron, how about tangent? What's the definition for tangent?
Is it x?
Nope, not x over y. Close.
Y over x.
Y over x. Okay. So take your y value and divide by your x value. So root 3 over 2 divided by -1/2. Okay. Now before I go any further, does anybody see what's going to cancel out there? The 2's. Some people like to take what's in the bottom, flip it, and multiply by what's in the top, multiply by the reciprocal. Okay. Or if you just see the 2's, that's exactly what would happen if you multiply by the reciprocal. The 2's would cancel, and I'd be left with negative square root of 3. Okay. Any questions on tangent? Okay. Now, Matt, we said earlier that there was a trick, that if you have any one of the numbers on the left, what to do to get the number on the right. Do you remember what you do with?
You put it under 1.
Yeah, which is basically finding the reciprocal. Just flip it. Okay, so that's what you get when you flip the sign. But Victoria, what's wrong with that?
In the denominator.
Right, we can't leave a square root in the denominator. Do you know how to fix that?
Don't you multiply that?
Yeah, multiply the top and the bottom by the square root. So you get 2 square root of 3 in the top. And in the bottom, you get the square root of 3 times the square root of 3, which is the square root of 9, or just 3. And that's what we're looking for. 2 square root 3 over 3. Katie, how about if I flip the cosine? What do I get for secant? Yeah, negative 2 over 1. You can even just leave it as negative 2. That's fine. So sometimes you flip it and you don't have to worry about the root. Orion, how about when I flip the tangent? There's no fraction here, so what could I do?
You still have to times it by square root of 3 over q, because you can't have the denominator square root over the denominator.
I agree with you, but I don't have a square root in the denominator yet. What do I have to do first?
You have to do the reciprocal.
Right, and what would be the reciprocal of this? Or if, what could you think of as being in the bottom here first?
1.
A 1. So if you don't have something, you can just throw a 1 in there. And now what would be the reciprocal of that?
1 over the square root of negative square root of 3.
Yep. And where you put the negative, it doesn't really matter. You can put it in the top, you can put it in the bottom. I usually just always keep the negative in the top. Okay, and Mason, could you tell me what I would get if I fix that so the root's not in the bottom?
Negative 3.
Careful, negative, square root's still going to be in there somewhere. Not quite. Ileana, can you help him out? Over 3. So when you multiply the top by square root of 3, it's just negative 1 times the square root of 3. And then multiply the bottom by square root of 3. And that's what you get. Okay, so what we just did there, that would be 6 separate problems on a test. Okay, I'm not going to have you do all 6 in the same problem. Okay, that would be 6 separate problems. Okay, any questions on that? All right. So this one says, find the 6 trig functions of this point, root 2 over 2, comma, root 2 over 2. And again, that's a point on the unit circle, and it represents an angle. I'm not going to tell you, again, what the angle is, but does anybody have a guess what that angle is? Root 2 over 2, comma, root 2 over 2. It's the coordinate for something we talked about. Katie?
45 degrees.
Yeah, that's the coordinate for 45 degrees. It's root 2 over 2, comma, root 2 over 2. For today, you don't need to know how to get that. Tomorrow, you will. You're going to have to figure out how do we get that. Okay, so take a couple minutes on your own and see if you can find the 6 trig functions for root 2 over 2, comma, root 2 over 2. So let's take a look at sine. So first one, sine. And how about Ashlyn? Were you able to get the sine for that angle?
Would it be, see it's the same, it would be square root of 2 over 2?
Yeah, and just so I know which one you picked, because usually it makes a difference.
The first one. No, the second.
The second one?
Yeah.
The y value. Yep.
Yeah.
So in this case, if you switched them, you wouldn't get anything wrong because they're the same. But in general, just make sure you remember it's y, the second one. All right, Peter, how about cosine?
Same thing.
Same thing. And which value was it this time, though?
The
The
first.
first one, the x. And Eric, how about tangent.
Square root of 2 over 2, and then divide by square root of 2 over 2.
Okay, so we've got square root of 2 over 2. That's my y. That's my x. And what do you get when you divide that out?
1.
1. You don't even really need to flip and multiply and cross things out because you're just dividing two things that are the same. Okay, so that's a quick one to flip. So Paige, let's do cotangent first just because it'll be a quick one. What do you get when you flip 1 over 1? 1. Okay, so the cotangent and the tangent are the same. Okay, Alex, what about my cosecant? Can you just tell me the first step before you have to do any more simplifying?
Put it under 1.
You put it under 1, which means to do what with it? Flip it. So what do you get when you flip that? Just the first step.
2 over square root of 2.
2 over square root of 2. And now what's wrong with it?
You can't have a square root in the denominator.
Can't have a square root in the denominator. So we'll fix it by multiplying by root 2 over 2. And Robin, what do I get when I finish that up?
2 square roots of 2 over the square root of 4.
Okay, so 2 square roots of 2 over, what's the square root of 4?
2.
2. And anything else I can do with that? Not sure. There's one more thing I can do just to simplify a little more. We've gotten pretty far, so that's good, but just one more thing.
Reduce the 2's.
Which 2's?
The one on the outside of the square root and the one on the bottom.
Yes. We can cancel that out. So all we get for the cosecant is the square root of 2. Okay, Connor, what would the secant be? Why would it be the same answer?
Because it's 1 over x, and x is the same as y.
Right. The sine and cosine are the same, so when you flip them, the cosecant and secant are the same. So there's your 6 trig functions for root 2 over 2, root 2 over 2, which is 45 degrees, but you don't have to know that yet. Okay. For this one, let's just do the first 3. Okay. We'll just find the sine, the cosine, and the tangent. Okay, Ryan, what would the sine be? Yep. And could you also give me the cosine? 2 square roots of 2 over 3. Yep, 2 square roots of 2 over 3. So for this problem, the only work we're really going to have to do is to find the tangent. And Emily, can you remind me again, what's my formula for tangent?
Or y.
Yeah, y over x. So negative a third divided by 2 square root 2 over 3. Okay, Cameron, anything I can cancel out?
3.
Yep, can cancel the 3's, which is going to leave me with negative 1 over 2 square roots of 2. And Faith, is that okay to leave like that? No. So what do I have to get rid of? Yep, got to get rid of that square root in the bottom. So ignore the 2 on the outside, that's fine. We just have to do something with the square root. And Rudy, can you remind me one more time, what do I do?
Just multiply it by the
Square
square root of 2.
root of 2 over square root of 2. So in the top, you're going to get negative root 2. And in the bottom, 2 times the square root of 2 times the square root of 2. Well, what's the square root of 2 times the square root of 2? Square root of 4, which is 2 times 2. 4. Okay, and there's your tangent. So sometimes there's a little bit of work you have to do to clean up an answer, flipping it and getting rid of the square root. Okay. Any questions on that one? Okay. Now, what's different about this problem compared to the other three we did? You have the angle, which directly doesn't help you. What do you really need?
Location.
You need the location for that angle. You need its coordinate. So that's the first step. So if I draw my unit circle, Mason, where is 90 degrees on this circle? It's at the top. And do you remember the coordinates for the point that's at the top of the circle? 0, 1. Now this problem is just like all the others. You've got your x, you've got your y, fill them all in. So Alex, what would be the sine of 90 degrees?
1.
1? Ileana, how about the cosine? 0. And Orion, can you just tell me not the final answer, but what would be the fraction for tangent 90? Careful, what's the formula for tangent? Yes. So what would that fraction be one more time? You said y. What value is y in that coordinate? Yes, 1 over 0. 1 over 0. Peter, what happens when we do 1 divided by 0? You can't do it, so what do we write?
0.
No, we don't write 0. 1 divided by 0, if you wrote 0, that means you can do it. Nope, not 1. To get 1, you have to divide two things that are the same, like 5 over 5. Undefined. Okay, so 1 over 0 is undefined. Any questions on that? All right, Zach, how about the cosecant of 90? Careful, you don't take the opposite, just the reciprocal. Just 1. Yeah. Okay. Rudy, how about the secant of 90? Well, what are you flipping? Tell me that first. To get the secant, you're flipping what fraction?
0.
You're flipping 0 over 1. If you want to make that a fraction, just put it over 1. Nope, not 1. It's undefined, right? Because if you flip 0 over 1, we just had that down here. 1 over 0, undefined. How about the cotangent of 90? Anyone think they could tell me what that one would be? Ashton?
Would it be 0 over 1?
Yep, 0 over 1. And what does that come out to? 0. Very good. So when you flip undefined, you get 0. When you flip 0, you get undefined. Okay, any questions on that one? Okay, so a little bit different because you had to figure out the coordinate first. Okay, so this one, again, it's just asking for 3 of the trig functions. And it's a little bit different again. Emily, can you tell me what's even more different about this one? So what does that mean? It's radians. So they're giving me an angle in radians. I don't have to, but what might make this problem a little bit easier if I do what with that? Yeah, Alex? Convert to degrees. And can you remind me how we do that?
You multiply it by 180 over pi.
Multiply by 180 over pi. And 3 times 180 is going to give me how much? I just think of 18 times 3 and put a 0. That'd be 20 times 3. We'll give you 60. 540. 18 times 3 is 54. Okay, so that's the angle I'm working with. Any thoughts about that angle, 540?
It's a little big.
It's a little big. So,
Subtract it by 360.
yeah, we can subtract 360 from it, okay, to make it smaller. Minus 360, and we get 180. Now from here, it's going to be just like the last problem. Draw your circle. Victoria, where is 180 on that circle? So like the top side, bottom, left, or right?
To the left.
Yeah, to the left. There's where we got to be. And Faith, do you remember the coordinate? If you go left 1?
Negative 1, 0.
Yep, very good, negative 1, 0. Now we just plug those into our formulas, and that's it. So Mason, can you give me the sign?
0.
Yep. How about the cosine? Negative 1. And Irene, can you give me the tangent? How did you, what did you use for your formula? 0 over, which is? Yeah, Ryan?
Isn't it 0?
0. All right, so here's a trick I use in Algebra 1. So if you have 0, let's do it like this. A number divided by 0 spells no. Okay, number divided by 0, you can't do it. No, undefined. If you have 0 divided by a number, it spells on. I have no idea. On. On, you're on track. Go ahead and do it. But number divided by 0 spells no. Don't do it. Okay, so that one is undefined. And this one is always 0. All right. Bless you. Okay, and why don't you try the last one on your own. Okay, it's very similar to the one we just did. Okay, so I would start with a conversion and then go from there. All right, so Peter, what's the first thing you did here?
I converted pi by 2 into degrees.
Perfect. And when you do that, what did you get when you did 11 times 180 divided by 2?
Divided by 2 is 990, and eventually ended up as 270.
All right, so you got 990
Yep.
when you did 11 times 180 divided by 2. And then how did you make it smaller?
Subtract 360 from the choice.
Yeah, this time you got to subtract 360 a couple times. And what did you finally get?
270.
270? Anyone else get 270 for the angle? Okay, good. All right, so we got our we got our angle, but again, that's not really what we need. We need where that is, not what it is. So Haley, how do I get the coordinate for 270?
Can you look on the circle and it's 0, -1?
Yep. Look on the circle. Just remember 270 is down, so it's 0, -1. Now we can go through our values. Eric, what's the sign?
-1.
-1. Paige, the cosine? 0, good. How about Molly, the tangent?
0 over -1.
No, that's a cotangent. So it's y over x,
Oh, so -1 is 0, but
which is undefined. Okay, so we got undefined. How about Robin, the cosecant?
I didn't get that far.
All right, what do you do with this value to get the cosecant?
Turn it around.
Flip it? Yep. And what do you get when you flip -1 over 1? Yeah, which would be how much? What would that reduce to?
Just 1?
Positive divided by negative?
-1.
-1. So we get -1. Alex, the secant?
Undefined.
Nice, undefined. And the last one, how about Emily? Cotangent? 0. Okay. Any questions on that? Okay, so that's the first part of unit circle trig. Tomorrow we'll look at how do we get the coordinates for angles that are 30, 45, and 60. So we'll look at that tomorrow. Okay, homework tonight. It's page 116. It's 11 through 27 odd and 22. If you're not going to be here for tomorrow any reason, I think tomorrow it's going to be a worksheet, but it'll be on the video as well if you need to get it from there. And you've got about 10 minutes left. Okay, so if you want to work with somebody, try to start the homework. You'll definitely get a little bit of time there to get going.